This video is going to introduce some OOPS concepts, classes, and objects. We're going to define OOPS, object-oriented programming, look at some tools that can use to create the design of your program. We're going to learn what it means to create an instance of an object, use the dot operator, again, a few more OOPS terms, and then talk about inheritance. So before we get started, pause the video right now, grab a sheet of paper and a pen, because periodically I'm going to ask you a question and I'd like you to jot down the answers. Our class is defining OOPS a little bit earlier than the textbook because we will be creating instances of objects very shortly before the textbook presents it. So I want to give you all that information. Remember, you're already working with objects from the Java library, so this gives you a foundation. Let's take a look at that image there. Classic Space Invaders games. I love this for teaching the concept of objects. There's a whole lot of objects, but mainly I'm looking at a whole set of alien objects coming down the screen, and then a set of 4 blockade objects coming across the bottom of the screen. One player object, it looks like. Each of those aliens is an object. So you have an option. You can write the code for, I believe, what is 55 aliens there, 55 times maybe, or you can write it once. What would you rather do? That is the advantage of object-oriented programming. Is you write it once, you can use it many times in your program, or you can use it in other programs. So once I have an alien, if there's another program that needs an alien, I can use that same class. Awesome tool. What is a class? Well, we've already used classes in our first few labs. A class is a blueprint to create objects. Now, there is the exception, and that is for what you've done. So the class that has the main method, and the main method is a static method. Do you remember the header used the keyword static? You're not really going to create instances of that. So that is the exception. We're starting with the exception, but we're moving on to the rule that the class is a blueprint to create objects. The best analogy in computer science for this is a blueprint for a house. So think about this. Is the blueprint the house? No, it's just directions on how to build the house. How many houses can you build? From one blueprint, I can build an infinite number of houses from one blueprint. Do you have to construct a house just because you have the blueprint? No. If you can construct many houses, do they have to be exactly the same? No, because they're going to be in a different location, they may be a different color, etc. So classes are blueprints. I can write a blueprint for alien there in Space Invaders, and I'll call it class alien. Whenever I want one of those 55 aliens to pop up on the screen, probably even at the beginning of the program, when the program starts executing, I will construct those aliens with a method that's in the class called the constructor. The process of me saying I need to construct an alien is called instantiation. Each alien is called an instance of the class alien. Okay, and the variable representing one of those objects that you create, okay, of those, say, 55 aliens, we'll call an object variable. And if you recall, you're going to follow the naming conventions we talked about last week. Object-oriented analysis and design, OOAD for the acronym, is how you're going to do the planning behind OOPS. It's always good to plan before you start coding. The tool we're going to use for planning is known as UML, Unified Modeling Language. When you model something, right, you're thinking of what it's going to look like before you actually build the real thing. And that's what we're doing when we use the tool called UML. And UML is very broad in scope when you start building systems. So here's class diagrams, interaction diagrams, sequence diagrams. We'll have a look at this in advanced programming. All I'm going to look at this semester is the class diagram. I'm going to try to keep it real simple. So here is an example of a class diagram for alien. Let's talk about that in a little more depth. So when you create a class, you're thinking about your object and you're thinking the data that the object needs to contain. And that data we're going to reference as property or attributes. So data of an object is a property. So look at Space Invaders to the right and decide, are there any data that one individual alien is going to contain? What makes the alien in the first row, the first alien, different than the alien in the fourth row, the third alien? So pause and think about that, and then when you come back, I'll come up with a possible list, which may be completely different. That's how coding is. So I decided the shapes are different. There's a X position and a Y position on the screen, and that's different. And the speed of descent, well, it could be, and I've played this game a long time ago, I think they descend at the same speed. So there's actually a property that lets you aggregate every object created with that class. So they all share that property, but they don't all share the same X position, right? This is a different X position than this. Now, a method is the behavior, what the object can do. We discussed methods last week. Recall the method machine. We talked about input going into the method machine and producing outputs. We're also going to have another video on methods shortly. So once again, let's pause the video and jot down what you think are some behaviors or actions that an alien object can do. And this is just totally arbitrary. I wrote get shot at. So the player's shooting at the alien. They can die. They can move. They can hit a player. They're coming down. They're coming down and they actually hit the player. Or they can hit one of the blockades. Definitely, they can shoot. Why do I not have shoot? They can shoot a weapon. Note, in gaming generally, a lot of these concepts, when you're hitting something, hitting a blockade is known as collision detection. Something for if you ever decide to take a game programming course, you'll learn all about it. Here is the URL generally, a template. It's just a rectangle, and you're going to divide it into 3 parts. The top part's going to just be the class name. The middle part's going to list all the properties for that class, and then the third part will name the methods. And I've actually added a little bit more to this class diagram. So those are the 4 properties I had on the previous slide. And you may have, as we said, come up with different properties. I also indicated the data type, which we'll be getting again more into. I referenced it last week. And then here are 5 methods. Here are the 5 methods I had on the previous screen. No right or wrong answer. Yours might be completely different if you thought about it. Once you make the class, and we're not making a class yet, we're just introducing the concepts, other than the class with your main method in it, you will need to be creating instances of that class. Now you're going to be doing some of that from classes that are in the Java library. So you're not writing the classes, but you want to be able to use those classes, and you'll be creating an instance. So the class itself is not the object. The class is the blueprint. And if you want to be able to use it, you have to construct, like you construct a house. You will construct an object with a statement that calls the constructor for the class. And you do this using a new keyword. So I'm going to build a new house. You're going to build a new object. That's going to be in the statement. And that statement, this statement here, is going to create an alien object. Now, when I first saw this statement a long time ago, when I first was learning OOPS, I thought, why do we got alien? This is confusing. It is. It's follow the pattern. And what this is saying is, I'm going to have an object variable called bad guy. And, well, what data type is he? He's going to be type alien. So this is the name of the class. And he's going to be equal to a new, and that's the constructor for the class alien. The constructor for the class has the same name as the name of the class. So these are actually 2 different things, but the rule that the constructor and the name are class name are the same puts 2 aliens in here. So this is going to create a bad guy that I can now use in my program. Now, So the above guy will create one alien named bad guy, and that bad guy is an instance of the alien class. You can create a second one. Let's say now this one I'm going to create a sweet alien. Same pattern. I'm going to create a object variable, sweet alien, of data type, or the class is alien. It's equal to new, and then that calls the constructor. Notice the parenthesis after the constructor name. So the constructor is like a method in the classes. It's a method source code in the class that creates the object. Any idea how many times you're going to have to do this in Space Invaders? So pause for a minute and think about how that can be done. Then we'll discuss a little bit of how you do it, though many of the concepts are coming in the next few weeks. Okay, so if you thought about it, did you count and see that there are 11 aliens in each row? There are 5 rows. Instead of creating an alien 55 times, okay, I would maybe create an alien. Oh, there's a number of ways to do this. Let's try the simpler way. Maybe I create this set of 11 aliens in a loop. Now, why you might want to do this is they all have the same shape, and they all have the same Y position, and then maybe every time through the loop, I increment the X position to set it over a little bit more, and then I do another 11, and then another 11. So that's one way you could create these really quickly. Dot operators are used to modify the properties. Property is the data about an object, and we have the bad guy object here. And how do I use the dot operator? Now, the dot operator is just a dot, okay? And the syntax to reference a property, such as the X position of bad guy, would be object name dot property name. So to change the value to the property, you're going to use what's called an assignment statement. An assignment statement as an equal to sign. So the syntax to change the property of an object is the name of the object, like bad guy, the name of the property, and you're going to write an equal to sign, and then the new value you want that property to have. Now this is a little complex. Example here, bad alien.x position. I'm going to change that to be equal to what? Well, let's grab the current X position and add 100. So what just happened? It just shifted over 100 pixels. When that statement executes, take the current position, shift it over 100 pixels. So pause right now. Think about how you might change the speed of bad alien. And did you come up with this? Bad alien, the object name, dot speed is the property name, equal to, and we're assigning the value 20 to it. Let's look at how you would use the dot operator to call a method. Now you have an object and it needs to behave a certain way. So we have our two objects, bad guy and sweet alien. The syntax is very simple as long as the method does not return a value or does not have any arguments. We make it more complex throughout the semester. But you're going to just do the object name, bad guy. I wrote bad alien there. That's a mistake. Bad guy dot method name. And those are the methods. So here's the example. Bad alien. It should be bad guy. Bad guy dot die. Okay. So whatever is in the die method is going to happen to your object. Maybe it'll add points to the player, for example. Whatever the person writing the source code in the class decides what happens when an alien dies. So I want you to pause and I want you to decide, how would sweet alien do the hit player method? And there it is, sweet alien dot hit player. That's it. It's pretty simple. So I want you to take time before you take the quiz, and if you look in the reading for the week 3 module in the OOPS basic concepts, you're going to find OOP, object-oriented programming, defined, encapsulation and information hiding, a little bit related, but you already know a little bit about Java libraries, and that you don't get to see what's inside that source code. So they're hiding things, and that's what classes do. And polymorphism means that a class can behave in multiple ways, and an interface is a tool that I need because when I have to work with multiple classes, I need to be consistent. So I can't say hit player for one method and player gets hit for another. Just is going to confuse your client when you're writing classes. So it makes you be consistent when you're creating the method names, etc., when you use an interface. Inheritance. In families, we have children that can inherit from parents, and we can do the same thing with classes. Now, these are all terms for the same thing. So you can have a parent class and child class, or class and subclass. So a subclass and child class are synonymous. Or you can also call it base class and derived class. But what do we mean by don't do the same thing? So let's look at this example of inheritance with vehicles. If you think, I'm going to create, I need to create a program where the player might choose a car or a boat or a van or a yacht, for example. All of those classes have things in common. So if you can notice the commonalities in those classes, you can actually save yourself time. A vehicle is the most general, and that's the parent. And what of these three classes what do all vehicles have in common? Well, all vehicles have a speed. So you can write the speed property in vehicle. Maybe they all have accelerate. Yeah, I think they all have accelerate and decelerate or brake. So all of those are methods that can go in vehicle. Then you can get more specific. A boat, I don't know a lot about boats, but they're going to have methods different than a car. Boats are going to inherit everything out of vehicles, and then the methods that are specific to boats can be written here. Maybe there are going to be properties in sailboat and properties in yachts that are different. But there are also properties in sailboats and yachts that are in common, and so they can be written in boats. Do you see how that's going to help you without having to rewrite some source code? Okay, so suppose you now have another class called boss alien, and he is an alien. This is an is-a relationship, but there are extra methods. So a regular alien cannot explode a bomb, but a boss alien can. You do not want to put explode bomb in the alien class, or all aliens could explode the bomb. So you're going to make boss alien a child of the alien class. It's going to be able to do everything an alien class can do, plus it can explode a bomb. Suppose you have a super alien class. It has the extra property of color and the extra method of shoot laser. That will become then a child of the alien class. So with inheritance, you don't have to rewrite any of the classes in alien in order for boss alien and super alien to use it. So let's take a look at the UML for inheritance. Notice I now have 3 class diagrams, and I have an arrow pointing from super alien to alien. That implies super alien is inheriting everything already here. I don't need to rewrite it. Notice you don't see it in this subclass. There's an arrow going from boss alien to alien. Again, boss alien automatically gets these properties and methods. Notice there's no extra properties, but there's an extra method called explode bomb. Review those OOPS terms and then get ready to take your quiz. Good luck.